Okay, so in the last couple videos we've been looking at arrays, and we've seen how you can use them to make things, well, they're basically like lists, right? They're these little containers, and they have a finite, like a set amount of space, and then you can put items into those slots. So they act like lists in that regard. And we saw how you could make them predefined, how you could just sort of make like an empty one. We used them to keep track of like grades as we have in this example. And we also looked at like menus and video games and stuff like that. So what we're going to do is we're going to keep building on that in this video. So what I'm going to do is get rid of all this. We're not going to use it anymore. And I'm going to make another array. So we'll start off with just a little bit of review. And we'll make an array of strings. And this one, I know what I want to put in it, so we're not going to use the keyword new here. So I'm going to call this list, or maybe we'll call it groceries. We'll be a little more specific. Because remember, if you can't be specific with your names, you should. Okay, so we're going to call it groceries. And we're going to make it just like that. Remember, the curly braces allow you to put items in here. And we're going to put in the list of groceries that we're going to need to buy if we go to the store. So we got eggs, milk, like soup, and then cookies. Everyone needs cookies. Alright, so there's our groceries. And then we want to print those groceries out. So in this case, I'm going to use the enhanced for loop because I don't really care about the index positions here. I just care about the different items that are in that list. So string, I'll call it G for grocery, N groceries. Then we're going to print G. So we're going to print each grocery. Save it. Compile it. No errors, but we did get a warning. Okay, it's because we're importing the scanner. That's okay. I'll actually go ahead and get rid of that. I don't think we'll need the scanner for a while. Okay. Eggs, milk, soup, cookies. So that shouldn't have been a surprise to anyone. This is something that we've been dealing with the last couple of videos. But now, I want to ask you a new question. What if I had more than one list? What if there were multiple people, maybe, living in some sort of an apartment complex, and they all had grocery lists? And someone in that building, maybe it's you, decided that they could make some extra money on the side by going to the store, because they needed to go to the store anyway. But they figured they could take the lists of everyone else that lived in that apartment complex. They could go and buy all of their groceries and then bring them back. So it's sort of like a delivery service. You give them the list, they go to the store, get all the stuff, and bring it back. So now they're going to have more lists than just this one. So I'm going to rename this grocery list so it's a little bit more specific. I'll call it grocery list 1. But then the little old lady that lives across the hall, she needs different groceries. She wants, I don't know, apples, and, I don't know, orange juice, chips, and that's it. She doesn't need a whole lot. Well, she's the little lady. We'll give her some prunes. Okay, there we go. So we can't just put these into this list, right? Because then you're not going to be able to keep track of who ordered what. We need to keep these separate. Because you don't want Miss Johnson's groceries to get jumbled up with yours. Otherwise, people aren't going to employ you. They're not going to ask you to go get their groceries for them if you can't remember what belonged to who. And let's say your business keeps growing. More and more people are taking advantage of this. And they're going and asking you to get their groceries. Onions, pizza, batteries, marbles, cards, chips, maybe some sort of a game night or whatever going on here. We'll get some dip for those chips. There we go. So I think that's enough lists to demonstrate the point. But if this business were successful, then you'd get more and more and more lists. So if you remember from one of the previous videos, I mentioned that if you ever ended up with this case where you had basically the same variable name, but you were numbering it, then it sounds like there's a data structure here. It sounds like there's a better way to represent this than just 1, 2, 3, 4. Because if you think about it, whenever we want to do something with all these lists, we're going to have to do it individually for each one of them. We'd have to make a for loop for every one of them, just like this. And that didn't take very long because I can copy and paste, but this is pretty ugly. And imagine if I had to go back and change it because something was broken. I'd have to change every single one of these. But we can run it and see that it works. So there's all the stuff that I need to buy, the one big list. But all this stuff is separate so that I can remember what belonged to who. So, because these are all distinct variables, we'd have to loop on them separately like this. So, in a previous video, I mentioned, like I just said, there's probably a hidden data structure here. But what could that possibly look like? Because we've already used our list, our array. Because each of these are arrays. So, it looks like we've sort of reached a dead end here. Like there's nothing more we can do. But it turns out, and this is actually really cool, what you can do, and I'll make another one. I'm going to call this one groceries. And we're just going to do it like that for now. Okay? So there we go. An empty one called groceries. So remember, an array is just like a box. Or like a set of boxes, sort of. It's like a case. And you come by, and each of these little spaces inside of it can hold one thing and exactly one thing. So it can hold a number, it can hold a string, it can hold a character, you know, what have you, whatever. And in this case, these are holding strings. But this is where it gets interesting. You can actually put another array into that box. So we can take this grocery list 1 array, literally just copy it, or I'll cut it, you grab it, and you put it into that other box. So just like this. And let me draw what that might look like. So you've got your normal array, right? We've seen this a bunch of times. Crudely drawn, but it's there. 1, 2, 3, 4, 3, 4, 5, and 6. So there's the array. And what we just did was we basically said, here, this box, position 0. Remember before we were just putting numbers in here, or we were putting words in here. But what we're going to do now is inside of this box, we're just going to put another array. And that's legal. 1, 2, 3. So we're just putting an array into that array space. And as you can probably imagine, you could do that again if you wanted. Inside of this array, you could put an array and just keep going forever. Like indefinitely. More than 2 or 3 times usually isn't all that practical. but you can put arrays instead of arrays. So let's go back to our example here, and you define it the exact same way. So I put a comma, and now I'm putting whatever's in that first position, or position 1, which is technically, I guess, the second item. And I want to put this list in there. And I'm trying to keep things nice and neat. There we go. Put a comma. Let's grab this next one and bring it in there as well. So we got a lot of curly braces going on. This can be a little bit difficult to read, but if you format it right, someone that knows what they're looking at will be able to tell what you're doing. And your name will always help as well. Let's actually call this grocery lists. And we'll get rid of this. And we'll get rid of this. And we'll comment this out for the time being. Alright. So we took all of those variables, grocery list 1 through grocery list 4, and we put them inside of this array. And we got something that looks like this. But another way to draw this, which might be more helpful, let me just make a new one. Don't save. It's bigger. Imagine if your array originally looked something like this, right? So this is your array. Well, when you put an array in this first spot, instead of thinking about it as like this little tiny little thing inside this box, if you imagine it like this, where it kind of hangs down, and the same thing for this one, and for this one, and for this one, so what does that look like? That looks kind of like a grid. So we know that this is index 0, 1, 2, 3, and 4 going across this way. And now we know that this thing's also an array. So that's position 0, 1, 2, 3, and 4. So we got a grid here. And the grid has rows, and it has columns. So the row is going to be whatever list it is. So this is the first list. This is the second list. This is the third list, and so on and so forth. So in our case, this is eggs. Eggs. This is milk. Soup. And this would be cookies. Then here would be apples, orange juice, chips, prunes, onions, pizza, batteries. We should probably put something else there. So the thing is, you got to keep it square. Everything inside this list has to have the same length. So if they're not going to buy anything else, we'll just put a null in there for the null string or the empty string. We could use the empty string. Don't confuse those together. There we go. So that would be how this would work. And this next one would be marbles, cards, chips, dip. So knowing that, let's try to grab some stuff out of there. So we got grocery lists. So I want to get batteries out of there. And we know that batteries is this one right here. So this is the list. This is the item. Or you can think about this as being the row, and this being the column. Okay. So we know that the batteries, they exist in list 2. 0, 1, 2. 0, 1, 2. So list 2, or row 2, then what item are the batteries in this list, now that we've found the list? 0, 1, 2. So the item at row 2, column 2, should be the batteries. And looks like we've got a mismatch. Oh, my mistake. So you have to add another set of brackets over here, because it's an array of arrays. So bracket, bracket. And that should fix it, hopefully. Yep. And we run it, and we get the batteries. Cool. What if I wanted the second item from the first list? Well, then I do that. List 1, item 2. And that's the chips. List 1, item 2, right here. Cool. So what about printing everything in there? What if I want to print all these lists out? Well, let's go down here and uncomment this code, and let's, oops, not comment, uncomment it. Okay. So we don't have strings anymore this first time. So if we want to use the enhanced for loop, which is what I'm going to use here, because I really don't care about the positions. I still only care about the actual items. I know that there's an array of strings in each of the positions of that first array, right? And we'll still call that, we'll call that list, because that's what it is. Each of these is the grocery list in grocery lists. So that's the first one, the second one, third one, the fourth one. Now for each of those lists, I want to grab the items. So for each item in that list, grab this, go back. For each item in the list, print out that item. And let's do something like, we'll just put a space. We could get pretty fancy with the formatting and put commas and stuff between them, but we'd have to do some checks to do that. Maybe we'll do that in a second so I can show you something else. But for now, and then I'm going to put a new line here. So I don't want to print anything, I just want the new line in between the lists. And compile, run, and we don't want to print that anymore. Okay. Just compile, run, and we get each of the lists printed on its own line. So that's pretty cool. So what if you did want to format this? What if you wanted to put commas between the different list items? That's not too hard to do. Just like that, right? Well, hold on. We got a comma at the end over here. That's not so good. We don't want that. We also got this null. We probably don't want to print null. So let's say if item does not equal null. So we'll get rid of that first. Alright, cool. So now we're not printing null anymore, so we're just printing what's actually in the list. But we still got this comma at the end. So what do you think? How might we be able to get rid of that? Think about that for just a moment. What makes this comma different than this one or this one? Or under what what situations do we want to add a comma versus which ones do we not want to? Take a second to think about that. Okay, so we're going to add a comma for every one of these except for the last one. Whatever exists in this last index, we don't want to add that comma. And I've just realized that this null is going to actually come back and bite us some more. Because batteries technically isn't at the last index position. Okay, getting rid of these commas might actually be a little bit more complex. It's definitely doable, and we could do it. But I don't want to overshadow the array practice that we're doing. So actually we'll just leave those there for now. But let's say you wanted to number the lists. So you wanted to say like list 1, list 2, list 3, list 4, so that you could keep track of what you were looking at. This list could get pretty long, theoretically, right? Well, what if you did something like this? So I'm just going to get rid of what's inside this for loop. And instead of using the enhanced for loop, the for each item loop, we're just going to use what we're used to. So int, we'll call it I equals 0. We'll call it row, actually, because that's what it is. While the row is less than grocery lists dot length. So it still has a length. In this case, the length is how many lists you have. And then we'll add one to it. So actually we could call it list. It'll be consistent with what we had before. We should probably call it row. Because it really isn't the list, it's the position of the list. And here, we're going to grab the list at that position. And we can leave this the same. Not too shabby. But before we iterate through that, let's print out what list we're actually looking at. And I'm going to use this formatting here. Just like that. And let's see what that looks like. Oh, printf. There we go. And we're going to run it. And list 0, 1, 2, and 3. So maybe we do row plus 1 so that it looks better for a human reader. There we go. So list 1 is eggs, milk, row, and soup and cookies. List 2 is apples, orange juice, chips, prunes. You know, there you go. So you can use both types of for loops when iterating through. This is called a two-dimensional array. It's got 2 dimensions. 1 dimension, 2 dimension. And you can also make a 3-dimensional array, a 4-dimensional array, and just keep stacking these things. But you don't need to know any of that for the AP exam. And in fact, you're very rarely going to use that many dimensions. So in addition to iterating through it this way, you can also iterate through it like columns-wise. So you could go, right now what we're doing is left to right, top to bottom, one row at a time, reading like. You could also read like this, like from the left, top down, then the next one, then down, then the next one. You would just have to change what the for loop looks like in order to do that. Okay, so hopefully that makes sense. So I'm going to make a new one. And we'll call this array practice 2. And I want to do one more thing. And then we'll call it for this video. So, if you can make a 2-dimensional array like this using these curly braces, just like we saw before, then it stands to reason that you can also make it using the new argument. So this time I'm going to use ints. And we want it to be a two-dimensional array, so we're going to do these two sets of curly or square brackets. Call it grid. And we're going to set that grid equals new two-dimensional array. And then you just have to put how many rows you want, how many columns you want. So row by column, that's the easiest way to remember this. Row by column. So we've got a thing called grid, and let's just print it out. And we're going to want a for loop. Because let me actually show you this, because I didn't show you in the previous videos. If you just print the grid, it's perfectly legal, you can do it, but you get this sort of ugly thing that doesn't really tell you anything. So we don't want to do that. So we want to do for int array of ints row in grid for int num in row, and this is where we're going to print num. Then between the rows, we want to print a new line. And we get this nice 9 by 9 grid of zeros. And what you can do, like we saw before, is int, I don't know, 4, 8 equals 2. Compile it. Oh, not int, grid. Sorry. Grid 4, 8 equals 2. Go to row 4, 1, 2, 3, 4, 5, because you can start 0, 0, 1, 2, 3, 4, all the way to 8, and you see it's now a 2. So there you go. There you have it. So you're probably wondering, well, what are some other cases in which you might want to use these? So a lot of times if you're making a video game or something of that nature, like a chess board, a Sudoku board, Candy Crush, Tic-Tac-Toe, checkers, stuff like that, it would be easy to represent the board as a grid, and then you could just put the pieces in these different spaces. There are other circumstances in which you'd use it as well, like this grocery list that we looked at. A list of lists can actually be very helpful as well. So hopefully all of this made sense. If not, feel free to ask me any questions that you have, and I'll see you in the next video.